ahead of the obstruction. Subsonic, these kind of pressure waves leading ahead of you, basically, which spreads out the individual shocks sufficiently that instead of a steep in wave, you get a shaped boom, something that comes on more acceptably. And it's been a great idea. It's been around a while. NASA actually began serious work on this topic when we were operating the SR-71s in the late 1990s, 1996 or 97. And we flew our SR-71 at various speeds. We chased it with an F-16XL, which could measure the pressure signature very close to the SR-71, further away. And then we even tested the same signature just above the Earth's boundary layer. And then we measured it on the ground as well. So, the SR-71 is a conventional supersonic airplane and produces a pretty serious sonic boom. But this was an experiment that let us validate our ability to predict how the signature changes in the atmosphere. So having done this, we then looked at a number of ways that you might shape the boom. And this was a large protuberance added to the nose of an F-15. Here's an F-5 airplane where the forebody has been replaced with a design intended to produce a lower boom. All of these projects were successful, and we're getting a high confidence that yes, we could change the shape of the boom on the ground. But the ultimate test, of course, for this kind of problem, it's not what kind of pressure signature you have, it's whether or not the public will agree that that's an acceptable sound. And so we also did a preliminary study using an F-18. And we actually went and did the study in the Galveston, Texas area. So the F-18 flies toward the coast, supersonic speeds, goes into a dive, does kind of an Immelman maneuver, and turns away without ever going over land. But it sends out a sonic boom over the community, which we felt was representative of what this kind of a quiet supersonic sonic boom might sound like. And this project involved going out and collecting community data, sending out surveys. You ask people, did you hear something unusual? Did you hear anything? What did it sound like? And you've got to kind of get this kind of feedback in order to make a convincing case that you've actually, reduced the sonic boom problem. Of course, ultimately, nobody's going to believe this unless you actually fly a supersonic airplane over the community. And that is the real purpose for the X-59. And this is the X-59 in a wind tunnel. And you can see it's in a perforated throat wind tunnel section, just like the X-1 proved out. And here is the X-59 in production in Palmdale. This is in the large Lockheed building that you can see from the freeway. The engine has already been delivered to Armstrong Flight Research Center. It's a GE 414 engine. And the hope is to be flying the airplane by next year, by 2022. It'll probably be a couple more years after that before we actually take the airplane to communities around the country where we're going to actually try to do that community overflight, fly it directly over a community and then take surveys and see what people think. The design goal is to go at Mach 1.4, an altitude of 55,000 feet. And the expectation is that it will produce a sonic boom that would sound more like a car door slamming, something that you might hear in a city anytime. And so if they're successful in that, that'll be a big step toward advancing supersonic transportation for, overland civilian use. So that's kind of the current state. And again, I put the talk together mostly to kind of emphasize that flight research is not the way it's often predicted. The public and, like you say, many people in aerospace tend to think of flight testing as just kind of a final demonstration. Like, we already know everything from theory and wind tunnel, and we're really just going to flight to kind of prove our point. In reality, there's many, many physical phenomena that you can't look at any other way than in flight. And so with that, anyway, I'd be glad to answer the question.
I'd like to ask one. It's a rather obscure question, but it's a question regarding supersonic transport aircraft, and it's what is a layman's explanation for why the center of pressure shifts aft during supersonic flight, which of course gives you much poorer lift over drag and range compared to saying sonically.
Yes, it's the same phenomena that you see in the wind tunnel. Because you're going faster than the speed of sound, you no longer have the pressure waves proceeding ahead of the obstruction. Subsonically, these kind of pressure waves leading ahead of you, basically begin to push the air away from the obstruction well before the arrival of the airplane. And so, subsonically, you get a large area of uplift before the wing, and before it circulates around and is pushed down. And, and that's why it's subsonically, maybe it's easier to understand why subsonically the center of pressure is really more around the quarter chord.
Right.
And with, once you go supersonic, you don't have any of this leading anticipation. The pressure behind the shock waves changes instantaneously, and it's almost constant throughout the supersonic portion across the wing. And so the low pressure field above the wing is somewhat constant, and so the center of pressure is going to be right dead center of it. And so it's a very dramatic shift from quarter chord to mid chord, and it changes everything. It's, as much as an impact on drag, there's also the problem that when you're building a supersonic transport, you have to have trim that can trim the airplane between, the difference in the CG and the aerocentroid being anywhere from a quarter chord to mid chord. And so you give up a lot of trim drag at subsonic speeds to allow that to be possible.
Would it be safe to say that of course, the aft of the shock wave, the air decelerates, pressure increases. Would it be safe to say that the shock airflow has essentially destroyed that low pressure zone forward to quarter chord that you see in subsonic flight? So therefore, you don't have that suction and that lift vector being generated at that point in the wing.
I'm not sure it has so much to do with the closure shock, just so much as the fact that you've had no acceleration of the flow prior to the leading edge.
Okay.
By the time the flow reaches the leading edge in a subsonic airplane, it is already accelerated. You already have a very low pressure in the air long before the air has reached the leading edge. And so I think that's why you tend to get the pressure spike moved forward of the center of the chord.
Okay, because
I have a question about the original flights of the X-1. Originally, it was flown by Bell, correct? Didn't they have a couple of airplanes?
In Florida.
And then Slick Godwin, or what his name was was the guy who got up to Mach 0.86 and said, I'll go Mach 1 if you give me $100,000. And at that point, it's when the Air Force took over, correct?
Yeah, that's all factually true. I think the X-1 was first flown in Evergreen, Florida, by Bell Aircraft, and they realized that it had such a range requirement that that's what prompted them to move to California and to Edwards Air Force Base. And all the things you said there, it's my understanding is that's all factual. I think it's all a little bit anecdotal. They have the movie The Right Stuff. They kind of recreate those discussions of, the contractor pilot was, holding out for more money. And, I have no reason to doubt any of that. But to some degree, I think it's a little bit anecdotal as people retelling the story a bit. But in general, it's absolutely true. And Chuck Yeager was, getting paid pretty low wages to just be an airman at the time, and stepped in and, if you read his book, he did it for the love of flying. He couldn't imagine why anybody wouldn't want to try to fly a new airplane like that.
Was it the same airplane that Bell had built?
There were several X-1s. Yes, the original X-1. They built, I think, at least two. They first did gliding. They did gliding tests at first in Florida. Then they put the rocket motors on. Then they had a really bad accident. They had an X-1 that was mated to the B-29, blew up in flight, and took them some time to find out what happened. And that's where they traced it down to. They were using kind of a cork-based gaskets for making seals, and they didn't know at the time that exposing it to cryogenic to rocket fuels would harden it and actually made it explosive. And so they had one of the original X-1s was destroyed in that accident. And then they had a ground accident with one of the X-1s, which was rebuilt, again, a rocket motor accident. And then the one that was used, it was the same design, although they obviously replaced the installations and things like that. After the initial program, of course, there were other versions of the X-1, the X-1E, the X-1D, which did even higher speed research all the way up to Mach 2.
So in the cockpit simulator we have, you can see 1, 2, 3, 4 for the engines or motors, whatever you call it, the rockets. But it only took them 3 engines to go supersonic, as I recall.
That's right. They were designing, again, part of the idea behind having rocket power for the X-1 was that, like I say, it really wasn't just to show you could go supersonic. They were planning from the get-go to be able to accelerate not just to the speed of sound. They wanted to confidently go to Mach numbers all the way up to Mach 2. They wanted to get Buffet data and such, turning at supersonic speeds. And all. So they had a lot more propulsion than they knew they needed. I believe on Chuck Yeager's first flight, I can be wrong, but I think he only used 2 chambers, actually. It's the account wrote he came off, he lit one chamber, did some controllability checks, and lit the second chamber and accelerated to 1.06.
In the cockpit simulation, we have, as I recall, the whole problem was the trim didn't work. You couldn't control the airplane with the trim, and so you had to do it with the flying tail, which had major ramifications later on, the F-86 and so forth and so on. But looking at the cockpit simulator, there seems to be a little stick sort of thing. I don't. Is that what they were controlling the flying tail with?
Yeah, that's a great question. I really don't know.
Yeah,
could well be. Yeah,
I remember when I interviewed General Cardenas. We talked quite a bit about it, and apparently they got up, I think, about the 8th flight or 7th flight, and it's still subsonic. And Chuck Yeager got up to 0.91 or 92, and he, nothing was happening. And that's when the co-pilot, who was an aerospace engineer, Tingsley, I think his name was, he was the guy that came up with the idea of the jack screw controlling the incidence angle of the tail of the horizontal stabilizer. So that's the story I've been telling. I hope it's right.
Yeah, the all moving tail is, that again goes back to the first question about, this fundamental difference between, subsonic and supersonic flow, where, at subsonic airplanes, all you do is move the trailing edge and you influence the whole flow field. You can increase lift on the whole wing just by moving the trailing edge flap. And of course, that doesn't work when you're going supersonic. You move the control surface and you get more lift just on the control surface itself. And so, yeah, it's the fundamental phenomena. You really want to move the entire tailplane to really have the full capability of trim.
Great, thanks.
Bob, you had a great discussion on the controllability or the anticipated reduction of the sonic boom for the folks on the ground. One of the other questions that I have is, like with the J58 engine on the Blackbirds, was there cavernous desire for a lot of fuel because they had to transition from an axial jet into a turbojet type engine? Were you involved with any of the engine developments that they want to push a transonic aircraft through the air with?
No, the SR-71s, when I first started in 75, NASA was flying the YF-12 airplanes, and they did a lot of research on the inlet, the spiked inlet, just because it was such a great full-scale test bed for that purpose. But I wasn't involved in any of that, and we didn't do that sort of research when we operated the SR-71s later. The the X-59, doing this work on the shape boom, one of the limits, it really is focused on the boom problem, and so there's no sense that, they're also going to be making the airplane a lot more efficient than the Concorde or things like that. But yeah, there's obviously a lot of other work needed to be done before the supersonic transports would be viable.
Yeah, thank you.
Okay, any more questions? Thank you, Bob, once again for a great talk.
Of course.
Okay. That's it for today.
Okay, thank you all.
All right, thank you guys.
Thanks a lot. It was great. See you next time.
Yeah.
Good talk.
Thank you.